Thank you. Thank you. Good afternoon. All right. Now that we got an insight about fuel, we'll try to get in deeper and try to learn more about the user-inspired R&D. And we'll start. I'll probably go ahead and introduce our panel up here. Russell Richardson, to my far right, far left, Senior Vice President of Business Development, Baton Rouge, here in Chamber. Probably Russell, you may want to speak a little bit more about you, and then I'll probably go introduce you.
Yeah, sure. Thanks for having me in today. So I'm with the Baton Rouge Area Chamber. We're one of the 8 regional economic development organizations in the state. My job at the chamber is to own the business development team, operating with projects and companies looking to expand in the area. So we see a lot of the projects in the areas we're talking about today in terms of energy, mainly around lately in hydrogen, ammonia, a lot of carbon sequestration component to them. So we see a lot of different projects. My background, I've been with the chamber for about 7 or 8 years now, worked at the state agency, LED, Louisiana Economic Development, for a few years. Came out of private business before then. So glad to be here. Thanks for having me.
Thank you, Russell. In the middle, we have Daniel Shantz, the Energy Chair in Clean Engineering, Tulane School of Science and Engineering, and also one of the PIs for the fuel proposal.
Yeah, so good afternoon, everyone. Thanks for the introduction. So I'm a faculty member in chemical engineering at Tulane. I was actually Ashwith's predecessor as the Use-Inspired R&D Director until very recently when I became the Associate Dean for Research and Doctoral Programs at Tulane. And this has been an amazing experience being involved with this group, and we're just at the beginning. And the level of interaction between so many partners in the states, in the state of Louisiana, just the universities, the corporate partners, et cetera, this is really an amazing opportunity for the state, and I feel very lucky to be part of it.
Cool. Thank you, Daniel. To my left, I have Jonathan Rouge, Executive Director of Institute for Materials Research and Innovation at University of Louisiana at Lafayette, and one of the co-PIs on the Fuel Awards.
Yeah, thank you, and it's a pleasure to be here. As you mentioned, I'm faculty in mechanical engineering at the University of Louisiana at Lafayette, and serve as one of the co-PIs. I've also had the opportunity to help co-chair the Use-Inspired R&D Committee, and I echo Dan's sentiments. It's been an amazing experience to see the different entities kind of come together so far as they have. The types of industry partners and academic partners that we've had in this room at the same time has really been phenomenal. And so fortunate to be here and look forward to discussion.
Thank you. And for Dan and Jonathan have been very helpful to me for me to getting on board pretty quickly, sweetly. And let's start with getting more details about it. So one of the missions of NSF Engines is to boost innovation capacity ecosystem. How does Fuel aim to achieve that goal, integrating an inclusive and innovative ecosystem here in Louisiana? And it's open for all, yeah.
Yeah, I'll start in terms of being an inclusive program. I mean, if you think about it, the opportunity that is here for the state, for our region in particular, it's going to take as many people as possible in different communities to bring forth to staff the level of opportunity that is out there. If I think about our region's kind of portfolio of projects, we've got about 50 projects that we're actively working, probably another 10 that we know of but have not put on the tracker per se. But those amount to $40 to $50 billion worth of projects. And probably anywhere from 15 to 20,000 jobs that are associated directly. And in economic development, we have these multipliers. You take that and you add a multiplier of 3, 4, 5 to those projects. It's pretty substantial in terms of the amount of work and people that will be needed should those projects begin taking place. So I think about fuel, I think about the program H to the Future that's been in place for a while. Even it was the hydrogen, was it HALO that there were the 8
yep.
programs throughout the country. You know, I tell folks a lot, you know, particularly when international companies come into the state or into our region, they see us, you know, Louisiana, Texas, Houston, it's all one market. It's the Gulf Coast market around the world. So we're part of that ecosystem. So you look at HALO, you look at H to the Future, you look at fuel, that's somewhere over $2 billion worth of federal monies coming in to our state and to our regions to assist in this process, coupled with that $40 to $50 billion worth of potential investment. Those two things alone, if that starts taking place over the next 3 to 4 years, that's generally what these projects, the timelines are from the time they say go. There's a lot of opportunity to include many communities and audiences that have not participated in that space up until now.
Yeah, I'll talk just from a kind of a programmatic perspective, right? So what we've tried to do on the R&D, on the use-inspired R&D pillar within fuel is to program in the kind of inclusivity component, right? So if familiar with the RFPs that are out now, we actually have requirements or strong requirements or needs for collaboration between different types of institutions, right? So there's an industry partner requirement, there's academic partner requirement, there's an academic partner requirement that's either an MSI or HBCU, and this is been really kind of transformative in itself. Not just the RFP, but the actual RFI process, right, has also brought together industry from the committee, industry partners, to put forth the industry needs, and then those RFIs were down selected from a committee, right, that was composed of industry members, academic members from different types of organizations, in order to ensure there's this kind of inclusive component. In addition to that, we have mechanisms for trying to build capacity for those institutions, the institutions with smaller research enterprise, or not, or they're not historically research strong, so that they can participate. And then I feel like once you get those different types of entities in the room together, collaborating, innovation is a natural kind of byproduct of that. So I think really from a programmatic standpoint, we're trying to tackle these two issues of inclusivity and innovation.
So my two prior colleagues here did a great job laying this out. I'll make just two quick observations. One that I found very fascinating to watch as we began to stand up the R&D pillar was that we went to different groups and said, what do you need? We can dole out money and run RFPs, but we actually asked the people we wanted to have engage in this, what is it you need that will enable you to be more successful? I think that stands out. The other thing more broadly, and I'm just involved with the R&D pillar, it has been amazing from my view watching this, the engagement with all of the stakeholders across the state. Having been involved with a range of federal funding, center level type activities, the engagement with the workforce development piece, you heard our colleagues up here before giving a great overview. It was amazing when NSF did the site visit a few years ago. We had sessions with the NSF visiting team where there was 120 different stakeholders in the room during the site visit. And that, more than anything to me, gives me a lot of confidence that we can meet our goals in terms of engaging a really broad, inclusive group.
Sure, thank you. I think capacity building, stakeholder engagement, and economic development is what I hear from this one. So now that we kind of got a better picture of that, so I know Dan and Jonathan, you were more on the RFP process. Can you share a few insights into the technology, the scientific areas that are into use in SPIDE R&D?
Sure. I mean, there's 6 broad areas that you can find listed through the website and in other places that involve things like carbon capture, utilization, sequestration, enabling the hydrogen economy, which has a lot of components to it, manufacturing, sustainable manufacturing. There's a energy efficiency component, water as a resource, and a policy component. Each of these areas have, quite a bit of overlap, as well as some, their own types of issues to overcome, technical barriers that need to be crossed. And they each have those barriers at different scales, right? So for my personal background, which is materials and manufacturing, I think about the enabling of the hydrogen economy, right? I think about it from a materials perspective, right? The materials compatibility issue. So we've got a long history in the state, particularly when it comes to LNG and some of the hydrogen derivatives. We've got a lot of built-up experience. We have some solutions, let's say, in the things like transport and storage of hydrogen, but there's still quite a few technical barriers to overcome. Things like bringing the cost down, reliability, and then that ties into well on the manufacturing side. So that's both a kind of benchtop scale problems that need to be overcome, as well as massive $100 billion infrastructure problems. And so I think that's kind of the unique thing there is the different scales that we have to tackle from a technical standpoint.
Yeah, and I'll follow up briefly on that. Jonathan did a great job laying that out. That I think one of the things here, so for the academics in the room who are familiar with the National Science Foundation, this is often very much basic science for basic science sake, which has been a wonderfully successful model for the country over the lifetime of the NSF. Whereas the TIPS directorate that's funding this, you heard bits and pieces of this alluded to, it's use-inspired R&D. So this is where the corporate engagement becomes essential, because we have a large number of the people who actually do the practice with a voice at the table directing what types of problems. The practitioners of these technologies have a better understanding of the limitations. If we want to get more specific, for instance, how could I modify my feedstock in my refinery to take recycled material and blend it in as part of lowering my carbon footprint of my feedstock? Someone in my line of work who works at a university simply can't figure out that problem from afar and what the challenges are, but the people who are practicing these technologies can. And I think one of the real values of the engine is it's a wonderful meeting ground for this really broad group of stakeholders.
Sure, and Russell, from Chamber's perspective, I know this is Indians is a place-based innovation initiative, right? So how do you see these new emerging areas to be fitting into the Chamber's perspective?
Yeah, just listening kind of Jonathan and talking through it there. Even around the infrastructure piece, I think for the projects that we have in place that are actively working now, power, sites and infrastructure are huge pieces. And across the country, there's a lot of demand for these projects. But in terms of these areas of focus for the program, I think for like carbon capture sequestration, there's a third of the permits across the country that are in Louisiana. And I would say, of that portfolio I mentioned, of that $50 billion, the majority of that has a carbon capture component associated with those projects. So in that regard, it is key to look at those types of technologies and start being an asset or being there for these projects and these companies, whether they're here or companies coming into the region looking to make investments. Another area that's probably for the capital region is hydrogen and ammonia. Those are probably a big bulk of that investment that I speak of. So RFPs around that area as well will fit nicely into companies trying to lower their operations cost, as well as capital costs for those projects.
That's great. So that brings me to my next question, that is how do we see these user-inspired R&Ds? I mean, the concept is still emerging, right? So how do you see we could build that or probably enhance user-inspiredness across the campuses or education institutions?
Yeah, I think it's a great question. And this particular issue is one where I think my institution, the University of Louisiana at Lafayette, is a kind of a great case study. So we like to say our research kind of tagline is research for a reason, right? It's very applied. We're always thinking about what the benefit is, right, to society, to the economy. That seems like it would make sense, but as Dan kind of alluded to, right, NSF's kind of an institution like NSF, right, a federal agency like NSF has traditionally been kind of on this other side, right, basic science, do the science for the sake of the science. And historically, I would say as an academic, right, there's almost been a different weighting, right, of the awards you may attract, whether it's federal agency or industrial partner. We actually kind of have instituted from a cultural perspective, right, there's a desire to build more relationships with industry. So we like to advertise, right, the fact that in terms of the ratio of research that we do, our research expenditures that are industry funded, we are in the top 10 in the country. And so it's been a real success from that perspective, as long as you consider that a success, right? And so I think there's kind of a need to have that be the focus kind of culturally within the institutions, and then give the investigators, right, the scientists, the academics, the opportunities, the space to build those relationships. And I think once they do that, once they're in the same room, which is what Fuel is doing, right, that kind of takes off from there.
I think Jonathan captured it well, and I'm at a small private university with a little different culture than at times some of the state schools. And I think to the points that if the faculty, one is you need faculty who value doing that type of work and want to be engaged in that type of work. I think that's one piece of it. I think that you mentioned culture, that's I think a good word for the universities to show that they mean that this is important and they value it, and there's a range of ways they can do that. I think the one thing that's probably a little underappreciated at times, and this is a broad observation, the students, so I have many undergraduates in my lab right now, and they're really interested in understanding, they really want to get into this space, right? They see climate change and all of these things, and there's a lot of concerns, and they're amazing, bright, dynamic young kids, and they want to change the world. And I think that this is one way that we can help affect this, you know, those of us involved with the engine, engaging with faculty who don't tend to think about this part of the research portfolio, that it's a really great, the best and brightest students want to work in these spaces. And so one of the ways to be successful is to work with really good people. So.
And adding on to the student engagement part, I think Lacey's session tomorrow would be pretty beneficial for some of that. And Russell, I know from science is produced in partnerships or collaboration. So how does those partnerships build, or how do you think they're translating research into economic development be perspective?
Yeah, I think particularly today, it is so crucial that those partnerships, you know, let's not just say we're doing partnerships, let's make it, let's be real and do it. And it takes a long time to get there and a lot of hard work. It's interesting, you know, just in the last 10 years or so, I feel like I've been doing this similar role for about 10 years now. It was not as integrated on projects when they come in. The projects come in, you know, the technology piece, they know where they're going, it's board approved, or, you know, they have their financing in place. You know, we get it, we work the project, it goes public, and off it goes. Whereas, you know, of that amount I just talked about, the $50 billion, I keep calling it, there's probably 25 or 30 that is in what is now, they say, feasibility. So meaning these companies are still putting the pieces of the puzzle together. So So back to your question about, let's make sure that we're aligned from a university standpoint, a government standpoint, with the companies doing all sorts of, whether it's public-private partnerships, CEAs, whatever that looks like, and working as a team. I go back to the H to the Future. I was on the original kind of conceptualization of that program, and it's taken a while for everybody to kind of form up. And I mean, Fuel's got 50 organizations involved. I think H2 is 20 or 25, something like that. So you have a lot of new people to the table, learning to work with another, learning to understand everybody's pain points, what causes tension, what their motivations are. And I just think, it's so important that piece comes together underneath, that you can talk about it, but it's difficult to make it happen at times. So you got to work at it.
Thank you. I know we're taking up the time up there. So 5 to 10 years down the line, how do you see you feel user-inspired R&D would position Louisiana as one of the global leaders in energy transition and also create those long-lasting relationships in Louisiana for all?
Sure, I'll jump in here. So in terms of the relationships, I mean, I think the biggest thing you need, and particularly between the scientists, right, on the research part, whether it's the scientists at different campuses or different companies, is just the time, right, the time together, and that's what this is offering. I've been fortunate to participate in a current, relatively statewide NSF-funded program. That's what's called the Louisiana Materials Design Alliance, where it's a similar, on a smaller scale, a similar idea that we want to bring universities together and build capacity. Well, having the ability to have that time to get to know the people you're working with, it's great to have. I mean, you need to have the alignment in terms of the vision, in terms of the science, the challenges, the resources, but ultimately you also just want to work with the people, right? And so having the time together is what this is really affording, and will really build those long-lasting connections, I think. In terms of 5 to 10 years down the road, what I expect to see are solutions, particularly coming out of the R&D pillar here, solutions to these technical challenges, likely from places that may not expect them to, right? Some, the institutions from that maybe aren't historically as research active, but were given the opportunity again to take a risk, right, to tackle these challenges. And so I expect to see solutions, and then those solutions transferred into IP and ultimately commercial activity. And I really feel like that'll serve as a model for other challenges going forward.
Yeah, I would echo the sentiment. I'm very positive. We have, right, one of the things in this state is that one view of it somewhat cynically is a lot of the country and the rest of the world is offshored their CO2 emissions to us because we make fuels and fertilizers and plastics. We have some of the leading producers globally in these spaces. So as an academician, I'm thrilled with the idea that this engine is going to let me engage with these companies that are world leaders in these spaces, who are very serious about moving forward. And so I'm quite optimistic that over the 5 to 10 year time frame, that as we, to Jonathan's point, figure out how to work together, because these university corporate partnerships, there are some dynamics around IP and different things that you can plan, but you have to get in and do to figure out how it will really work. So I'm very optimistic that there's going to be some substantive technical solutions over the time of the engine, which should be 10 years.
Russell?
Yeah, I mean, that question makes me think of the previous question. The better we set those partnerships and execute, the better we'll come out in 5 years. Like I said, these projects are on 5-year, 4-year timelines. Let's put that practice in place and be ready for them, help them move at the speed they want to move at.
So building on the relationships, I get that.
That's
yes.
right.
Thank you. With that said, we'll wrap it up and probably take some questions from audiences here.
Yep, just a couple of questions from the audience. The first is, the previous panel had talked about CO2 as feedstock being a prime opportunity for Louisiana and that it's a chemical engineering challenge. My understanding is Texas has been doing this for years. Can you tell us what Texas is doing to utilize emissions in the product life cycle and how Louisiana can build on this?
So what is,
Chemical engineer talking.
yeah, I'm the chemical engineer up here. I think I have to answer this one. So when we're referring to what Texas is doing, so there's a range of ways that people are thinking about utilizing CO2 right now. And this can be as a reactant in making existing molecules like propylene, which is a monomer for the value chain, down that value chain. Certainly in what I'm going to call the net zero space, one of the things that's attracted a lot of excitement, and this is not a new story, is the idea of taking carbon dioxide and converting it to methanol. Once I have methanol, I can make all the molecules we use today to make plastics, liquid fuels, et cetera. And in full disclosure, I actually lived in Texas for a little while, so I'm not sure. I think there's a lot of different pieces going on there. If we set aside sequestration and we think about how I would work carbon dioxide back into different things. And methanol is one logical molecule. There are others, and there's a lot of people thinking about this. Another one that is widely touted is taking methane or natural gas and reacting carbon dioxide with it. This is a way to generate hydrogen and molecules I can use to make fuels and other things with, where I'm using the CO2 as a feedstock, and if one could do this, you'd do it at very large scale. So I'm now showing my chemical industry and not petrochemical industry bias. So hopefully that addresses a little bit.
Thank you. Our next one.
Yep. Next question is, how do we provide research resources to HBCUs and community colleges?
You're the expert.
Yeah, cool. I'll probably pick it on that one too. Yes. So one of the funding mechanisms that we have in user-inspired R&D is inclusion funds, just so to build capacities aligned with fuel. And as we speak, the community engagement portion kind of aligns with some of the companies to build capacities for HBCUs, MSIs, and community colleges to proactively engage them into the engine. And as I think in the previous panel we mentioned that some of the RFPs do have HBCUs as a key or mandate required to have them as a partner. So just certainly to build capacities and build an inclusive ecosystem of innovation here.
Right. Yeah, I think it's really important to show that there's, in addition to, direct capacity building, there's going to be the kind of indirect capacity building that comes through the partnerships that we're getting from the various projects, and that's going to be the really lasting impact.
And I think we have time for one more question is, what are the metrics for success that you are currently tracking?
I'll take that and probably, Mike, you want to go for that?
Sure. So with the understanding that we're, as you heard from the prior panel, we're literally in the first funding cycle. So to that end, this is part of the learning experience. And if you get to Rebecca Sherman's panel tomorrow, she may or may not share this. Part of what we're doing in the first year is we're standing up this machine from pretty much ground zero. The different programs will have different targets. Presumably in this first round of RFPs, the grants are going to be on the order of a year in time. They will have to have well-defined performance metrics. We need to hit these milestones. And then we come back in another year for additional funding. You can imagine as the engine evolves, if we want to cast this in the context of TRLs, in different places on the readiness ladder, that we're probably going to go to more mature projects as the engine gets deeper into the 10 years. Whereas at this initial cycle, one of the big pieces for us from the National Science Foundation viewpoint in this first cycle is certainly getting the research done is one important piece, but showing them that we can run and administer a machine like this efficiently and learn from what we will likely make mistakes and learn in this first cycle and integrate those and improve this to go better. So,
yeah, I think you well captured it. Yes, thank you. Do we have another question?
No more questions.
Oh, great. I think we're on that. Pretty great. Thank you all. Thank you, the panel. Thank you.